The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and welcome to the PTV Talks session for today. Supplementing public transit with on-demand services, a case study from Zurich. We will start in 1 minute. We'll just give a few people a time to connect to this session. So in 1 more minute, we will start this session, giving people an opportunity to still log on. Again, good afternoon to the PTV Talk session for today, supplementing public transit with on-demand services, a case study from Zurich. I'm standing in here for our regular host, Adam Groves, who is on business travel today. So if you have missed the first few editions of the PTV Talks, the PTV Talks is a series of regularly scheduled web sessions that we launched in response to our clients' request for additional content as a way to deliver product information, use cases, training material, and other educational information to our users. Throughout this series, we will have PTV staff, clients, and other industry professionals presenting on various topics. We would definitely like to have your feedback on what type of content you would like to see. So please feel free to submit any requests, comments, and suggestions to info.us@ptvgroup.com. In this webinar, mobility analyst Christoph Baur from the Zurich Transportation Authority in Switzerland will highlight the future of mobility strategy for the Zurich Public Transit System and tools used to pursuing a strategy, the approach and the strategy to mass design for on-demand services, complementing their bus and rail services. The presentation will highlight how Zurich plans for future transportation while adding an Uber pool alike on-demand services into the mix of transportation solutions that they have already offered. So Christoph will give some insight in the expected mode shift for the new on-demand services coming from other modes, and he will also highlight how on-demand services can be put in place or cannot be put in place in cities with high density demand and cities with already high quality public transportation systems in place. So at the end of this webinar, you will all be able to you will all be given the chance to ask questions about the project, the goals, and the outcomes. But first, I would like to give the word here to Christoph. Christoph, you can come on if you like, and also take over the presentation. And from here on, the floor is yours, as we call it.
Okay, then thank you for the introduction. Hello, or grüezi miteinander, as we say in Switzerland. So we'll start the presentation now. Come on. Okay, so it doesn't work. Okay, it's a bit slow. So there will be 4 parts of the presentation. First of all, it's important to understand how the city of Zurich works in terms of traffic in order to understand the background of our mobility strategy and the mass study. Next, we have to look into the mobility strategy of the Zurich Transport Authority and into our simulation study with PTV Mass Modeler. Finally, I would like to give a brief outlook on an upcoming study for a citywide scenario. Just have to put on the laser pointer. Yeah, okay, good. Yeah, the first point, understanding Zurich. Zurich is actually very small compared to other metropolises, especially outside of Europe. There are 420,000 people living in the city itself and 470,000 jobs. The agglomeration in the canton of Zurich consists of approximately 1.8 million people. Therefore, there is a high number of commuters who commute to Zurich every day. As the operator of the bus and tram lines, we carry more than 1 million passengers every workday. The figures for the S-Bahn lines, S-Bahn are suburban trains, and other train lines are not included here. Also, we have no subway lines in Zurich. Next slide. Okay, good. Local politics in Zurich are very clear that private car traffic should not and must not given priority. Among other things, the municipal code stipulates that the modal split share of bike, walking, and public transit should increase by 10% in 10 years. Or to put it in other words, the share of private car traffic has to decrease by 10%. Here on the top right, you can see a typical street section inside Zurich city center. And that's a big main road with about 20,000 vehicles per day. Of course, it's immediately noticeable that there's simply no room for road extensions. There is no possibility to give more space to cars in the city area. Nevertheless, there are up to 100% separated bus lanes or tram lanes, and furthermore, bus and tram are prioritized at all intersections with traffic lights and almost always gets green immediately without having to stop. This, of course, makes public transport very attractive in the city. Furthermore, there are expansion programs for bicycles, and walking is just as attractive due to short distances within the city. All this leads to, oh, come on, doesn't work, no. What happens? I'm still online?
I can click here.
Okay, doesn't work now. Huh. Yeah, okay, that's good. All this leads to the corresponding modal split shares of 75% for city-compatible modes of transport shown here on the right. If you look at the traffic at the city borders, so it's a bit slow, huh? Can you click, please? Okay, if you look at the traffic at the city borders, you can see that the S-Bahn lines have grown considerably since 1990 compared to road traffic. In the morning rush hour, car traffic is metered at the city borders so that the urban network does not collapse. This means that hardly any growth is possible in private motor traffic. Next slide, please. Okay, I hope it could be made understandable in the short term what importance public transport has in Zurich and must continue to have in the future in order to keep up the city running. So let's now take a look at our future mobility strategy. Again, yeah, next slide, please. Yeah, next slide, yeah. What future can we expect for cars? At the moment, we are still in the field of evolution here. More and more technology is being installed in private vehicles as driver assistance systems and so on. These make driving safer, but have little or no effect on the frequency of use. The number of vehicles on trips therefore remains more or less constant. The urge to drive autonomously leads to innovation. Here, vehicles can drive autonomously, but are still privately owned. Thus, the car is also available to other population groups, such as children, and the car can drive back home to the parking lot, and so on. This could lead to more vehicles and much higher number of trips. In the area of the at the moment existing sharing economy, we see a reorganization which brings people together in one vehicle or allows several people to use the car one after the other. Here only slight declines are to be expected for trips and vehicles. And the big challenge will be to combine innovation with reorganization to a revolution. only then will we succeed in significantly reducing the number of vehicles and trips. However, this requires a change of society, and we don't know how strong this will actually be. Okay, now it works, the slide. Okay, perfect. So we are actually faced with the following question. Are we entering a mobility hell with significantly increasing number of trips through innovation? Or are we entering a mobility heaven through a revolution in our mobility behavior? Of course, we are working towards the mobility heaven, but we must not close our eyes to a possibly contrary effect. To underline the points mentioned, have a look at this photo montage from Zurich's Bahnhofstraße. In reality, it looked like this. So, does it work with a laser pointer? No. Huh.
I can try.
Okay. Okay. Can I just skip the screens? It should be open. Okay. So now let's have a look into Zurich Bahnhofstraße, how it looked like in reality. So here you can see a small road with tram tracks inside, and people can cross the street with no problems. It's a very nice area. It's also dense, and you have some street coffee and so on. It's a very nice area. And if you go back to the presentation here, yeah. So have to look at the photo montage, and in order to achieve the same performance as the tram tracks shown, at least 5 lanes would be needed for car traffic. You can do it electrically, you can do it autonomously, but it is and remains a traffic jam and too much traffic for the city. Zurich will not function without public transportation in the future either. These boundary conditions lead us to the following vision of our future mobility landscape. As a backbone, there will and must continue to be powerful systems such as the suburban railways and an improved high-performance urban transport network. Within the districts, okay, the slide will not come here. Okay, within the districts, however, it is quite possible that there is either something with on-demand ride pooling and or district bus lines. The blue area is the one on which our mass study is based. More on this in the next slides. It would also be possible to offer a kind of premium service, for direct connection between the districts. Since it has to be expected that the road network will not be able to take up car traffic in the future, an access restriction for private-owned or private used cars would be an option in the 3 central areas of the Zurich downtown or Zurich Altstetten and Zurich Oerlikon. The interchanges should take place at mobility hubs, which will enable access to further transport systems with national, regional, or local scopes. As mentioned above, we now turn our attention to the blue area of the mobility map, our mobility landscape. Yeah. Here we have the FlexNets project we launched. FlexNets means something like flexible network. Here we want to test an on-demand ride pooling system. First, we want to start with 5 vehicles with the option of 2 more. The operating time will be only between 8 p.m. and 1 a.m. We want to ask ourselves whether we can replace a single small bus line and accompany this with simulation studies on PTV Mass Modeler. It will also be fully integrated in the existing pricing system without any surcharges and with our own drivers. Nevertheless, there are several partners in the background. I unfortunately cannot talk about yet for contractual reasons, but it will be a white label offer and thus for our customers still a VBZ service with VBZ drivers at the VBZ fares. The start for our customers is planned for September 2020. Yeah. We want to gain initial experience with the FlexNets project, and together with PTV, we have also created a simulation here. However, the effects are very small due to a small number of vehicles of 5 or 7 vehicles. This was to be expected. A somewhat more exciting simulation case is a study with 100 vehicles in the same area as the FlexNets, which I will show you now. Yeah, the next point, simulation with the mass modeler. Why did we even think about a PTV study here? The main reason is that many providers just wanted to sell us their ride pooling algorithm. But for this algorithm, we need demand as input, but we don't have this input. Together with PTV, we were able to create this demand with our existing traffic demand model. In addition, we wanted to be able to build up our own on-demand ride pooling model independent of external know-how. And what did we do that for? We wanted to get answers to questions like what happens at which fleet size and which modal shifts can be expected, which parameters of quality of service can our customers expect. And this point is really important for Zurich because we are well known for our perfect and good public transportation service. And of course, cost efficiency is always a question. What have we achieved in the simulation project? The most important point, demand is an output parameter. And it's not just an X% of existing demand from other modes scenario like the most other studies. We also have an iterative behavior between supply and demand. In this way, we want to correctly reflect the fact that on-demand ride pooling systems have capacity limits during peak hour. If those are achieved due to high demand, the performance for our customers decreases, for example, longer waiting times and so on. They will then be more likely to switch to other modes such as the existing reliable mass transit system. This in turn leads to lower demand for on-demand ride pooling, which improves performance and generates more demand and so on. So we have here the loop. In addition, the traffic effects across all modes of transport are predictable depending on the design of an on-demand ride pooling system. And we managed to implement intermodality via a hub. Here, passengers can switch between mass or on-demand ride pooling and public transit. Apart from these advantages, there are still challenges. So we do have a hub, yeah, but it's unfortunately just one hub. Our future mobility landscape includes more than just one hub. And we have almost no empirical data for on-demand ride pooling for the model setup. Currently, a mix of existing parameters of public transit and car is implemented. So the mass system can be understood as something in between. But we will soon start with the FlexNets, and here is an accompanying scientific study. So this will also be able to provide us with some parameter values for Zurich. So let's now have a look at the model area itself. Yeah, here in this blue area, okay, the laser pointer is gone. Here in this blue area, the traffic system mass is allowed. In this area with approximately 80,000 inhabitants and 50,000 jobs, up to 100 vehicles may drive. In the red circle is the hub where you can change to other public transport lines in different directions. All public transport lines will be kept up. So we have an additional system which can be called Uber at PT fares, or what happens if tomorrow there are 100 self-driving Google cars. So it is also a kind of competition analysis and in the sense of what if. If you zoom in a bit, the so-called PUDOs can also be recognized. PUDO means pick up and drop off points, or in other words, all permissible virtual stops. These are the red guys here. The points marked with the H are showing existing public transport stops. And yeah, this is roughly explained the model setup on which our current analyses are based. Here, the model split is shown in the corresponding area without the mass systems or on-demand ride pooling. In comparison to the model split shown at the beginning, walking is more pronounced in this area. Next, the mode mass is implemented with the shown supply and demand loop here. And here we see the demand of the system, and here the number of the simulation run. The first 10 runs are initial runs without interaction of supply and demand. In this area, the loop starts, and you can recognize that the system is very attractive at the beginning, but the quality seems not sufficient, which results in less demand in the next iteration and so on. From this point on, the system has leveled off at a stable state. After 40 runs, there's no more trend in demand to recognize, and the simulation is terminated. So what does the model split look like now? Only about 4% can be served by the mass system with 100 vehicles in this area. In the public transport sector, a decline of only 1% can be observed, but also from walking and bike, and sure, a bit of car, but yeah, also just 1%. This leads us to the following conclusion. The existing public transport network in this area is very dense and still attractive for our customers. And that's a very reassuring result for our management, of course. But what do these 4% mean for the for the road network? Here in this picture, you can see the number of vehicles movements and not the number of passengers. So also empty vehicle trips are shown here. You can see accentuation toward the hub, which is plausible on the one hand. On the other hand, it is also encouraged by the model setup where people are forced to change modes at Bahnhof Altstetten here. Nevertheless, there are up to 1,000 on-demand ride pooling vehicle trips per working day in this area. You may ask if this is at all possible with this infrastructure. Yeah. Of course, a conversion would be necessary in the future, but is that what we want? Also with the thought that shares from the modes walking, bike, and public transport will be won, which is not really the goal of the city administration. We want to reduce the mode car and not squeeze more vehicles in the network filled with people from modes walking, bike, and public transport. Next. Okay, good. There are, of course, further results like how many vehicles are actually required, economic efficiency, and so on. However, these are not yet so interesting for us in this context. Of course, it is more expensive and less economical to operate with so many vehicles, especially as long as a driver has to sit in them. Also, the bundling effect of a bus or a tram is always better, especially with a double articulated bus like this one in the picture. Yeah, let's come to the last short point of the presentation, the upcoming citywide scenario. Okay. Yeah. First of all, oh, that was one slide too far. Okay. First of all, we are still at the very beginning, but the goal is to find out which impact has to be expected from different scenarios of robotaxi implementation in the area of Zurich, and which deployment policies should be set up. Among other things, we want to build a citywide scenario and see what happens in Zurich, as mentioned. One result should be to derive recommendation for city regulators to keep the network running. In this study, we are a project partner with the Canton of Zurich and PTV under the scientific direction of the University of St. Gallen and the University of Minnesota. So it's not our own project, but we are partners in this project. The completion of the study as well as the publication of results is planned for about mid-2020. So if you are interested in the results, just give me or PTV a short hint. It will be published in English, so it's good for you to read. And yeah, that's it. Thank you for your attention, and I think we will start now with the Q&A round. Is that right?
Yeah, that's correct. Let me have a look if there's any questions already. Thank you, Christoph, for your presentation. I see here there is some questions already coming up here. Let me see if I can get my screen a little bigger so that I can read them. Second. Let me see. We go up to the top here. So first, Christoph, thank you for your presentation. I think it's good to see that urban density and demand density is clearly a determining factor in designing your on-demand transportation system, and also how your urban infrastructure and the existing road network, of course, determine the possible options for a transportation solution. As I also think, like on-demand is always possible when you can still serve enough people who can travel in times comparable to car travel times. But what you also showed, I think, is that you have to keep an eye on the opportunities for bicycles and pedestrians, especially if you talk about smaller areas. Maybe those types of modes are definitely to be considered as part of the mass offering. So I think it's really interesting to see how you have this integrated approach and how you cannot see the one independent from the other. So thank you for that. What I see here, there are some questions in here. Let me see if I can. I have to find a way to make them all possible to read. Okay, here. The first question is will the 2020 project involve autonomous vehicles or driven vehicles?
It will contain driven vehicles. We want to separate this. If you talk about mass, everybody thinks about autonomously vehicles. They do the operation electrically. We wanted to separate this, and in this project we want to get some experience with on-demand ride pooling, and there is no need to do this electrically or with autonomously vehicles.
Thank you. And then the next question here is the ride pooling many to few destinations, many to one, many to many? How did you set up your ride pooling concept?
The concept here is you are able to go to any point as you want, but in the results you will see the accentuation to the hub, and so it's a many to one direction, I think. Yes.
But in the end, just to clarify on the question, people can go from anywhere to anywhere within the zone. They don't have to go to one specific location or start at one specific location.
No, they can go where they want. Yeah.
Yeah. Okay. Hopefully that responds to the question here that I have from Steve. Another question here. We see here. What is the area in width and length of the study area was the question.
That's hard. I don't know. Let's think about it. Maybe 5 kilometers. Yeah, okay. Is it good for you to talk in kilometers? 5 kilometers per 5 kilometers, I think. I don't know the length in miles or something like this. Sorry for that.
5 kilometers by 5 kilometers, you're saying?
Yeah, it could be. It could be possible. Yeah.
Right. The question here about the robo-taxi was: is it a shared or individual vehicle? Probably.
For the upcoming study, I think we will do this with shared vehicles.
Okay. So the vehicle is not only shared when a person is ready, but the ride is shared. Multiple people in a trip, right?
Yeah.
Okay. Next question: can fare policies encourage grouping of riders? Discount to one hub, one grocery, and a pharmacy.
Sorry, I didn't get this point.
Yeah. Can fare policies encouraging a group of riders? For example, are you planning to use fare policies in the pricing, saying, hey, if you all want to go the Bahnhofstrasse, as you mentioned, then you get a different price if you all go.
Okay, sure. No, we want to do it with the policy that you have buy one ticket and you can use all modes of public transport, and mass system should be part of the public transport network.
Okay, thank you. The next question here is that's a similar question. How does the model consider fare integration? So they say it's important for mode choice, right? So if you have like a monthly commuter pass, can you just use your on-demand service as much as you want, or how does that work?
And yes, that's right. If you have a ticket or a monthly ticket, yeah, you can use mass system with no limitation. And in the model setup, we just put the existing price model of the public transportation also for the mass system. It's the same.
So price is also an evaluation factor in your mode choice mode choice evaluation.
Yeah.
At this time,
it's not as much as detailed as it could be, but it's a factor. Yeah.
Okay, I'm curious to know, as a question from me in between, is the price of parking also considered for people who take their car?
Yeah, it's also part of the model. Yeah.
Okay.
And it is really expensive to get a parking lot in Zurich downtown. You have to pay for it much.
Right. That's why everyone travels by public transportation in Zurich.
Yes. Yeah.
Okay.
And not the only reason, but one reason, yes.
Right. It's also faster than taking the car, as much as my experience is. Is that correct?
Yeah, that's correct. The first point is to get in the city. The second point is to find a parking lot, and the third point is you have to pay for them.
Right. All important factors in mode choice. Okay, a question here. Out of the 100 cars that were used, what is the utilization of the fleet? Like, is it, for example, like 60% of the 100 vehicles are not empty, are vehicle miles with passengers, and 40% is empty rides? Do you have an idea about what the occupancy average was, or how the average percentage of empty vehicle miles traveled?
Yes, this is also an output parameter, and I have not the graphic here, but the 100 vehicles are only used in peak hour at the afternoon. The whole day there are about 40 to 60 vehicles used. At nighttime, only 10, I think. This was the key facts in this slide.
How did you determine those numbers of vehicles, the 40 or the 60? Also based out of the analysis?
Yeah, it's an output parameter. You have the demand and put all the people, or try to put all the people into the pooling algorithm, and then you can see how many vehicles you need.
Right. Okay.
Need.
And here's another question. In the 100 vehicle scenario, it sounded like 1,000 trips were served to the main hub. In the time period, does that mean only 10 trips per vehicle per day during the day, or during some type of a peak period?
It was the number of vehicles per day moving in this area, and so yeah, every vehicle is going up to 10 times to the mobility app. It should be the correct conclusion, yeah.
But was that 10 times per day in that matter? Because that doesn't sound like a lot. That was, I think, the question from the people that are asking the question.
Yeah, you can think about this like this. That's right, but it's 1,000 vehicles more in this area, and this is the key fact. It's very hard to get them into the existing network with only 2-lane road, which is already full of cars.
Okay. Yeah. Next question here. I mean, looking at the time, we still have like 10 minutes. We still have some questions ahead of us. Did we consider a scenario when the choice between personal car and mass break even? I don't know.
Yeah, as in this study, we just do the analysis of the existing setup of state from now. We have there no future implementation of the traffic like how it look like in 2030, because I'm not able to answer this question. I have no idea how traffic with mass or autonomously driving should be working in 10 or 20 years. I have no idea what we can do. We can do something like this. Yeah, sure. It's no problem. But if this is reality in 10 or 20 years, I don't know.
Right. Other question, and I think you kind of answered it already, is like, how will the scenarios consider fares of future vehicles? Because I believe, right, oh, go ahead.
Go on.
No, I was thinking you were saying that it was already in that the fare is just a standard public transportation fare, right?
Yeah, that's right. But we can the model setup. We can do also set up the prices up or set up the prices down and see what happens. That is possible with the model, but it was not scope of the study.
Right. Another question is, how will people go to a bus stop? How did you plan for that?
Yeah, they go there they walk to the bus stop. Here in Zurich, you have every 300 meter a stop of public transportation. It's a very dense network. Or they do something like micro-mobility with e-scooter or something like this. But everyone talks about the first mile, the last mile. But if you travel a mile in Zurich, you may hit your destination already. So it's a very dense city, and our last mile is maybe the last 200 meters, something like this.
So another question here is, if it is true that on-demand transit only has a minor effect on car use and mode split, why should the city of Zurich allow and finance it?
It's a good question. Everybody is talking about the systems, and yeah, this would be the future. I've shown that the model split shares are not as much as expected, and it's not should not be goal to reduce or to put up some modes from public transport, bike, and walking into such systems. But we also have to gain experience with this mass system, and it would be possible that such systems are great for regional areas. So we just wanted to gain experience there, and yeah, it's Switzerland. We have a bit of money and do it.
Right. And also what you're saying is what you're saying, hey, even if it probably doesn't work in high density areas, you're basically gaining experience to go further out of the city and use the experience for the lower density areas and make the transportation access better in those regions.
Yeah, the most important point is to get experience there. We don't have any clue how Zurich people would react to such systems. We don't know it. So we do we do a real life study here.
Okay. Another question is, in the study, did you keep the public transport lines in the ride pooling service untouched?
Mm-hmm. Yep, they're all public transport lines kept up.
Right. Okay. Let me see here.
But just a second. In this study, I have shown with the 100 vehicle scenario, all public transport lines are the same as before. But we also have the idea to reduce service on a small district bus line. Within the real life study I told a few seconds before. So we want to replace a single small bus line with 7 on-demand vehicles and see what happens. This is part of the real life study, but and we also did a simulation, but the effects are very small, so it was not so exciting to told about this.
Okay. Another question here is, does the model consider the technology access barrier based on demographic data? Does the model assume that the use of a smartphone technology is available for everyone?
Yes, every group of people is able to get into these modes, and this is yeah, as I told, we don't have any parameters for the model setup in of real life experience. So we do a mix of these public transportation parameters and car parameters. And if you're able to get in public transportation, you are able to get to the mass system, and there's no extra factors for smartphone use and so on.
Okay, thank you. Then another question is, how do you manage vehicles which are not in use? Do you plan for special parking or have a special parking policy for those vehicles that are not being used?
For the model setup, it has no matter. The vehicle just stand up in the area and no one cares about it. But with our 5 fleet vehicles or 7 vehicle fleet, we have plans to get them back to our depot, our garage. It's yeah, this could be possible, but if we have a 100 or 1,000 vehicle scenario and in real life, this would be a big challenge to get the fleet management right, especially in finding parking lots and so on. It's a big issue.
All right, thank you. Okay, I'll go through 3 more questions and then we get to our end here.
Okay.
Did we? Another question is, did you consider excluding walkable areas of, like, say, a kilometer or 1.5 kilometer radius from the DRT service? Is that something that was considered?
No, people can move as before in the model, and yeah, that doesn't matter.
Okay. Let me see here. One last question. Let me see. Let me see. Which is the average time passengers have to wait at the hub to transfer to get ride pooling?
Oh, that's a good question. In the 100 vehicle scenario, it's still attractive. I think about 2 or 3 minutes, but I'm not really sure about this fact. And yeah, it's attractive. You have to wait, yeah, sure, but not as much as we expected.
Okay, good. I think that concludes the questions, and I think that also brings us to an end here for our webinar. So yeah, I want to thank you, Christoph, for joining from Europe for an international audience, because I understood there's people from all over the world listening in. So thank you for doing this at 6 o'clock your time. It's 9 o'clock LA time. I'm saying it's probably pretty late in Singapore. So maybe one of your most international presentations of your career. I hope that people have learned something new here, and of course that they can use this experience to create their better cities all over the world. And as I stated earlier, if you have questions and you want to contact either Christoph or PTV, do not hesitate to contact us. You can see here the info and the addresses here, email address info.us@ptvgroup.com. Also, we can connect you then with Christoph if that's what you desire. The presentation and the recording will all be posted on ptvtraffic.us under the resource tab. The link is also on this on the bottom of this presentation. So with that, I would like to conclude this session and want to thank everyone for their interest. And hopefully we will see you again at the next PTV Talks. Thank you for your time, Christoph, and we look forward to working with you in the future on your 2020 project. It's very exciting. Thank you so much.
It was a pleasure. Thank you.
Okay, bye-bye.